All right, eighth grade. Today we are checking out Topic 8, Lesson 3, Initial Value. And as we look at this, we are going to be also calling initial value the y-intercept. So those two terms are going to be interchangeable. So let's check out our warm-up problem here. At a school craft fair, you sell t-shirts of your own design for $6 each. And right off the bat, when I see something like $6 each, this tells me that I'm going to be charging an amount and it's going to change based on how many I'm selling. So I'm thinking right off the bat that this sounds like my rate of change, right? How much I make is going to go up $6 for every shirt I sell. So I'm going to be doing $6 times X. So we're selling these shirts for $6 each. You bring money with you to make change. This money that I'm bringing with me to make change, this is what we're going to call our initial value. And if you think about the word initial, it means first, or what you have at the beginning. So what I'm starting with, my initial value, is this money that I'm bringing to make change as I sell these t-shirts. So I don't know what that is yet, so we're going to have to figure that out. After selling 5 t-shirts, you have $44. Well, to help us organize this information, let's make an XY table. And I know that X is going to stand for the number of shirts that I sell, and Y is going to stand for the amount of money that I make. So if I know that I am selling shirts for $6 each, when I sell one shirt, I should make $6. When I sell 2 shirts, I should make 6 times 2, or $12. When I sell 3 shirts, I should make 3 times 6, or $18. When I sell 4, 4 times 6 is 24. 5 times 6 is 30. So after I have sold 5 t-shirts, I should have made $30, and I can stop here. But what I know is that after selling 5 t-shirts, I actually have $44. So 44 minus 30 is going to give me my initial value, or that money that I brought with me to make change. So I actually brought $14 so I can make change as I sell these t-shirts, and now I'm going to make $6 each time I sell a t-shirt. So let's make a new XY table. Now that we have found how much money we brought to make change, that's the 14. Now let's show our solution in a table. So we're going to make a new XY table, and this one is going to, again, show the number of t-shirts I've sold. But this time I'm also going to add in the money I started with. So in the beginning, I have $14. So when I sell one shirt for 6, I have 14 plus the $6 that I make on that t-shirt. So after selling one shirt, I actually have $20. When I sell 2 shirts, I'm going to make $12 off of those 2 shirts. Plus, I have the 14 that I started with. So 14 plus 12 is 26. And each time I sell another shirt, I should make another $6, right? So when I sell 4 shirts, that's $36. When I sell 5 shirts, that's 44. And I apologize, hopefully you caught my math there. When I sell 4 shirts, that's $38. So this is what we call initial value. So what you really want to be able to do in the end is say that Y, the number of dollars that we make, is $6 per shirt, so 6 times X, plus the initial value, that $14 that I started with. And if I add all of that up, that will give me the total money that I make. So that is your goal for today. I can determine the rate of change, which is this, and the initial value, which is this, of a linear function. So that's what we are working on today. So let's talk about some of this vocabulary. We've been talking about linear functions for a while. Linear meaning straight line, function meaning that I have an input, my x, and that produces an output of a y. And for every x, there can be only one matching output. And we've talked about testing that with the vertical line test. So when we are writing a rule for a linear function, we are going to use this form here, y equals mx plus b. And what's great about this form is just by looking at this equation, I can see both the rate of change, which is my m, and I can also see the initial value, or my y-intercept, which is the b. The x and the y stand for every ordered pair that is a point on this line. So this y equals mx plus b form is something you will use a ton in algebra next year and will continue to use a lot this year. So it's important to remember the pieces. M is our rate of change, which is the same as our slope, and b is that initial value, that amount that we start with, and we'll also call that our y-intercept. So let's check out the graph. We can also see both the rate of change, or my slope, and the initial value of the function when we look at the graph. So let's check out this graph. Here's my line. I'm going to trace over it in blue. This is the graph of a linear function. And I can look at this and I can see the slope of the line, which we call m in our equation, and the slope is also the rate of change. Remember, we have calculated that slope or rate of change by picking points on the graph, and from one point to the next, we calculate the rise over the run. So to get from this point to this point, I need to rise 1, 2, and I need to run 1, 2, 3. So I would say that my slope, or my m, is 2/3. Every time I'm going to rise 2, run 3, rise 2, run 3. And as long as I continue rising 2, running 3, I will continue to find points on this line. My initial value, or my y-intercept of the line, is going to be where my line crosses the y-axis. That's my initial value. So in other words, when x is 0, where is my function? So in this case, my initial value, my y-intercept, is right here at +1. It crosses the y-axis at +1. So this point is 0, 1, and that's my initial value. So in an equation, I see the slope, or the rate of change, here. And on my graph, I see that by calculating the rise over the run. And in my equation, I see the initial value here. And on my graph, I see that as the point where my line crosses the y-axis. So let's practice with that a little bit. As we're looking at linear functions, we are going to look for this y equals mx plus b form. So as I look at these 4 linear function rules, I want to try to match them with their initial value. So remember, our initial value is our b. So it's the number that I'm adding to my x term. My m is what I multiply by x. So whatever number is attached to the x, that's your slope, or your rate of change. The constant value, the one that's not attached to x, is always going to be our initial value. So as I look at this first equation here, y equals 3 minus 3x. I see that the number attached to x is this -3, and my initial value, the constant that I'm combining with this x term, is a +3. So this equation has an initial value of 3. And if I rewrite it in this way, it might help us see that better. Y equals mx plus b. This is a +3, so I can put a plus sign in front of it. This minus sign goes with the 3x. So I have just rearranged these using the commutative property to put them in the opposite order. So y equals mx plus b form. +3 gives us initial value of 3. Let's look at our next equation. Y equals mx plus b. So my initial value is this constant term that I'm adding, a +2. So this equation would fit here. The initial value is 2. All right, let's look at our third equation. Y equals 2x plus 3. Y equals mx plus b form. So this is my y-intercept, which is a +3. So this equation has an initial value, or a y-intercept, of +3. And my last equation, y equals 3x minus 2. This is in y equals mx plus b form. My b is my initial value, which is a -2. So this equation has an initial value of -2. And we didn't end up with any that had an initial value of -3. So pause the video so that you have a chance to practice this, and then you can check your answers with mine. We're looking for which linear functions have an initial value of -4. So think of y equals mx plus b form, and we're looking for which equations have a b value, or an initial value, of -4. Pause and then check your answers. On equation 1, y equals 4x plus 5. This is y equals mx plus b form. My b value, which is my initial value, is a +5. So that is not a value of -4. As I look at equation 2, I have y equals -4 minus 5x. I'm going to go ahead and rewrite this in y equals mx plus b form so that I can see it easier. Notice I'm keeping the sign with the number that follows it. So y equals mx plus b. Here I do have an initial value, or a b, of -4. So this function does have an initial value of -4. And finally, y equals -4x plus 5. Y equals mx plus b. My b is a +5, which again is not an initial value of -4. In this case, I have a -4, but this -4 is my m, or my rate of change, or sometimes we'll call that our slope, and we always use m to represent our slope in our equations. So our -4 in this equation is the rate of change, or the slope. All right, let's look at a real-world example so that we can try this out together. I'm going to start with this example on our next video.